Good day, ladies and gentlemen, once again. So today we're going to do a question paper on June 2015. Uh, we have the following statement. Remember, I said the given part is very, very important. So now we're going to go through the given part. We're given A with the coordinates -4 is to 2, and then we're given B with the coordinates 3 is to 4. And we are given C coordinates 1 is to -3, and they say A, B, C are points on the Cartesian plane. So now remember, we have to analyze the Cartesian plane. So now here is our Cartesian plane. We have A, we have B, and then we have C. So now what is the new thing that we have here? That is the angle. So they tell us theta, they gave us theta. So now remember, when they give you angles in analytical geometry, you need to check whether those angles are angles of inclination or what. So now remember, I said angle of inclination is measured from x-axis to a line. So now if you draw that line and it's measured anti-clockwise, so now we can see that theta is an angle of inclination. So now to find theta, we can use m equal tan of theta. So this is what we know about angle of inclination. So that is very, very important. So now let's go to the equations, because there's no given part. They did not tell us about the midpoint or anything. So now going to the given part, they say calculate the gradient, determine the gradient of AC, and that's for 2 marks. So now how do you determine the gradient? We know the formula. The formula for determining the gradient is m equal y2 minus y1 over x2 minus x1. So now remember, I said you need to name your coordinates. So now if you come here, they say they want the gradient of AC. So now you can just say the gradient of AC. So now we need to go to AC. So here is our AC. So we need to name the coordinates. So we can make this one x1, y1, and then this one x2, y2. So now once you have named your coordinates, remember what you need to know. Remember the second part. After naming your coordinates, you take the same coordinates and substitute them into the formula. So now from our naming, what is our y2? It's visible that our y2 is -3. So we have -3 minus. And then what is our y1? We just take it from the naming. So our y1 is 2. So we take the same 2 and then substitute it there into the formula. So we have -2 all over. What is our x2? We go to the naming. Our x2 is there. Here is our x2 is 1. So we have 1 minus. And then what is our x1? We go to the naming again. There is our x1. That is -4. So we have -4. So now this is the gradient of AC. Therefore, the gradient of AC will be, we go to our calculator, put it in the calculator. We have -3 minus 2 all over 1 minus 4. And then that is 5 over 3. So we know the gradient of AC is 5 over 3. Now we check. Look at AC. It is a decreasing line. So our gradient is positive. So we made a mistake somewhere. So now let's go ahead and rectify that mistake. You see, with these things, if you get a negative, if you get a positive gradient, whereas your line is decreasing, it means you need to go back and rectify the mistake. So now the mistake that we made is with 4. So remember, the formula is x2 minus x1. So our x2 is 1, and then here is 1 minus x1. So our x1 was -4. So that means we needed to have negative 4. So you see, you don't panic, you just relax and rectify the mistake. Let's go ahead and see what's going to be the new answer. So 1 minus into negative 4. So the answer is negative 1. So since the line is decreasing, the gradient has to be negative. So the answer for 1.1 is negative 1. So now let's go to 1.2. They say calculate, determine the midpoint M of AC. So now AC, M is in the middle. So this is our M being the midpoint. So that means this part is equal to that part, since M is the midpoint. So we need the coordinates of that M, because remember, we have two formulas from our previous discussion. Remember, I said you use this formula if you have the midpoint, and you use this one if you don't have the midpoint. So in this case, we don't have the midpoint, so we can use this one, M x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. So now look at the nice thing here. We have named our coordinates AC. When we are finding the gradient, we named the coordinates, so we can just put them. So what's going to be our x1? There is our x1, that's negative 4. So we will have negative 4 plus. And then what is our x2? There is our x2, that's 1. And then we will have plus 1 all over 2. Now going to y, what is our y1? From the naming, that's 2. So we will have 2 plus, and then what is our y2? From the naming again, there is our y2, that's negative 3. So we have plus negative 3 all over 2. And now we just put the whole thing into the calculator. Negative 4 plus 1, that's negative 3. So the first one will be negative 3 over 2. And then we have 2 plus negative 3. That's going to be negative 1 all over 2. So now this is the coordinates of the midpoint M. It has those coordinates. So you can, from this step, you plug this in your calculator, it will give you this one. You plug that in your calculator, it will give you that one. Don't try to do the calculations by head. You just substitute into the calculator. So now 1.3. Remember, if the question tells you something, or the question inquire about something that is not in the sketch, you need to create an image. That's the first step of you need to follow of solving these analytical geometry problems. So now 1.3 says determine the equation of the straight line. So now they're talking about the straight line. We know the equation. It's going to be x, this one. So we are going to use this equation to determine the equation of that straight line. So now remember, y1 and x1 is any point that is on that line. So now let's go ahead and read the information. They're saying determine the equation of a straight line parallel to AB. Okay, here is AB. So that line is parallel to AB. And then they're saying it passes through M. So that means if we were to draw a line that passes through M that is parallel to AB, obviously the line can't go down, but it has to go in that direction. It has to go in that direction such that the two are parallel. So now, what did we say about the gradient of parallel lines? We said if two lines are said to be parallel, that means they have the same gradient. So now with this line, the only coordinate that we know, since they told us it passes through M, we know the coordinate of M, that is negative 3 over 2 and negative 1 over 2. So we know the coordinates of M. Now we need the gradient. Remember, this M is going to be y1, and x1. So now we need the gradient. So now how do you find the gradient? You use what we have learned previously. What we have learned previously is that if two lines are said to be parallel, and then we know that they have the same gradient. So now if you come to the sketch, are you aware that it is possible to find the gradient of AB because you have two coordinates? So we can find the gradient of AB. So now let's go ahead and do that. The gradient of AB will be y2 minus y1 over x2 minus x1. So now we need to name the coordinates. So now we know this is x1, y1. So now we can make bb x2 and y2 and then make substitutions into our formula. So what's going to be our y2? That's 4 minus, and then our y1, there it is, that is 2 over, and then our x2 from the naming, that's 3 minus, and then what is our x1? There's our x1 there, that's -4. So we have minus -4, and then therefore the gradient of AB will be, you put that in a calculator. So you have 4 minus 2 divided by 3 minus -4. So that is 2 over 7. And it's positive, so that is 2 over 7. Let's confirm if it's correct. The line is increasing, so the gradient, the value of the gradient is correct because it's also positive. So now what did we say about the parallel lines? We said if the gradient here is 10, then the gradient here has to be 10. Why? Because the two lines are parallel. So now the gradient of that line that is parallel to AB is equals to 2 over 7. Why are we saying the gradient of that line is 2 over 7? Because parallel lines have the same gradient. So now we use the formula y minus y1 equal m into x minus x1. So now remember, y1 and x1, they are what y1 and x1 are just, they are just a point that passes through, that is a point on that line, or a point that this line passes through. So we know that this line passes through M. So we can just say this is going to be our x1, and then this is going to be our y1, and then we make substitutions into the formula. On the side, you can just highlight -3 over 2 and -1 over 2, and then that will be your x1, y1. And we know the value of m, that is 2 over 7, and then we make substitutions. So this is going to be y minus so now what is our y1? Our y1 is going to be -1 over 2. So now I want to be fast. Since this is negative and that -1 over 2 is negative, so this negative and that negative, it will make positive. So we will have plus 1 over 2 equal. And then what is the value of the gradient? We know that line is the gradient of 2 over 7. So we have 2 over 7 into x minus, and then what's going to be our x1? That's going to be -3 over 2. So now this negative and this negative, they make positive. So we will have 3 over 2. So now let's go ahead and simplify. 2 over 7 times x, that's going to be 2 over 7x. And then we have plus 2 over 7 multiplied by 3 over 2. The 2 will cancel, and then we'll be left with 3 over 7. And then that 1 over 2, if it goes to that side, we will have minus 1 over 2, and then we'll be left with y. Therefore, y equal 2 over 7 x, and then we just use a calculator to find what is 3 over 7 minus 1 over 2, and then we get minus 1 over 40. So we have the equation of that line that is parallel to AB. So guys, whenever they give you something that is not in the sketch, draw it and create something out of it. Try to understand it. So now we're going to 1.4. So now let's see what 1.4 has for us. So now they're saying in 1.4, determine the coordinates of D if ABCD is a parallelogram. So now this thing is in order, guys. Don't make a mistake. It's in order. So this is A, and this is B, and this is C. Obviously D has to be somewhere here. So now they need to be in that order. So we have our D there, then we can just join the points. So now this is what we have. Let me draw an imaginary sketch. So we have something that's like this. And I want you to see here. This is A, that's B, and that's C, and that's D. So we have the midpoint, which is M. So remember, in the previous videos, we just join. So if you join, what do you know about the diagonals of a parallelogram? We know that the diagonals, they bisect. So now, if you look at this part, if you look at that part, if I were to draw it here, guys, use the same idea always. You will never go wrong. So you have the coordinates, which is -3/2, -1/2. You have the coordinates of B, which is 3 and 4. So are you aware that since M is the midpoint, we can use the second formula to find D, which is this one. Why are we using this one? Simply because we have the midpoint, which is M. So now we can use the second formula. XM equal x1 plus x2 over 2, and then ym equal y1 plus y2 over 2. And then now, what is our xm? Remember, xm is just the value of x at the midpoint. So what is the value of x for at the midpoint? That is -3/2. So xm will be -3/2 equal. And then what is x1 and x2? Remember, I said x1 and x2 are outer points. So the outer point is first is this one. We can just call it x plus, and then what is our second outer point for x? This is this one, which is 3. So 3/2. And remember, I said if the denominator is the same, we can just equate the numerator. So we will have -3 equal x plus 3. And then if you transpose 3 to that side, you will have -3 minus 3 equal x. Therefore, x will be -6. Beautiful. So now we're going to do the same thing with ym. Guys, this question repeats itself. We might find it in another video. We will still use the same approach. Don't be confused. Just relax and apply this concept of diagonals. So now let's go to ym. What is our ym? That's just y value of the midpoint. That is -½ equal. And then what is our y1? Remember, y1 and y2, they are external points. So y1 can be here because remember, we have x and y. y1 can be here. So we have y plus. And then what is our y2? It's going to be at b, which is 4 over, and then over 2. We said if the denominator are the same, and then we just equate the numerator. So -1 will be y plus 4. And then if you take 4 to the other side, you will have -1 minus 4 equal y. So -1 minus 4, that's -5 equal y. So now, what are the coordinates of D? So D has the coordinates -6 is to -5, and you get easy marks. So now let's go to the last question, which is 1.5. Guys, what I want you to see is the pattern in solving analytical geometry problems. Observe how I solve them. and then believe me, you'll master these things when you attempt them on your own. So now there's 1.5, they want the size of theta. And remember what I said. We said theta is an inclination. Why are we saying it's an inclination? Because it's measured from x-axis to a line, and it's measured in an anti-clockwise direction. So now, and we said, okay, if theta is an inclination, then to find it, we have to use that formula, which is m equal tan of theta. So now we ask ourselves questions. Which gradient are we going to use? Remember, it's from x-axis to a line, but which line? The line BC. So now we need the gradient of line BC, because here in this formula, we are going to use the gradient of BC. So now let's go ahead and find the gradient of BC. The gradient of BC on this side. We know the formula for gradient is y2 minus y1 over x2 minus x1. So let's go ahead and name. So from our naming, we have x2 and y2, and then we have x2 and y2. So we can make one be x1 and y1. So this one will be x1, that will be y1. So now we go ahead and try to substitute. So now what's going to be our y2? We just read from that. That's going to be 4. So we have 4 minus, and then what's going to be our y1? From the formula y1, and then it's going to be -3. So we have minus -3 all over. And then what's going to be our x2? We go to the sketch. We said our x2 is going to be 3. So we have 3 minus. And then what's going to be our x1? We go to the sketch. That's going to be 1. Beautiful. So now we put that in your calculator. Therefore, we'll get the gradient of BC. So that's going to be 4 minus -3 over 3 minus 1. That's going to be 7 over 2. So that's 7 over 2. So now we know the gradient of BC. We can just substitute it there. So we will have 7 over 2 equal tan of theta. So now you know from solving trigonometric equations or from solving general solutions, to get theta, we just say theta equal arctan 7 over 2. And then if you plug that in your calculator, second function tan of 7 over 2, it gives you the value of theta, which is 74.05 degrees. So that's 74.05 degrees. And then you get full 14 marks. So now, in our next question, okay, this will be our next question of discussion. This question, which is a very nice question, but you need to be calm if you attempt this question. So now that we have the given part there, remember I said the given part, it's very, very vital. So now they say triangle ABC. Can you see that we have a triangle? Okay, so now we're done with that statement. It has A, B, C. A, which has the coordinates 4:3, B, 3:-5. Okay, no problem. We see them as points on the Cartesian plane. We can see that one. These are points on the Cartesian plane. No problem. We know that if there's no sufficient information, we just go straight to the question. So now the 2.1 says determine the equation of a straight line that is parallel to AB and passes through C. So now they say that line, guys, parallel lines are just lines that are like that. So the two lines are parallel. So if they say that line passes through here and is parallel to AB, So that means that line, it has to be somewhere here. You see the relationship between the two lines, AB and this line. So that means we know this one is parallel to that one. How do we know that they are parallel? Because that they told us. So now, what is the first thing that you need to know to do? Since they're talking about the equation, what must come to your mind is the formula y minus y1 equal m into x minus x1. And you know y1 and x1 must be the point on that line. So now let's go ahead and try to attempt this. So this is 2.1. This is 2.1. So now, since we know, you can start by identifying the formula. So you know y1 and x1. So which point lies on this line? Which point lie on this line? Obviously, we can see that's point C. So now you know that you can highlight that point, which is -3 and -2. And then you know that this is going to be your x1 and your y1. Now we're missing the gradient. So now how will you find the gradient of that line? But since we know that, okay, that line is parallel to AB, and we know that parallel lines have the same gradient, we can find the gradient of AB, and that will be the same gradient for that line. So now let's go ahead and find the gradient for AB. The formula, it's y2 minus y1 over x2 minus x1. So now, remember, the gradient formula, the distance formula, and the midpoint formula, you need to name your coordinates. So now let's go ahead and do that. So this is going to be our x1, and that's y1, and then that's going to be our x2, and then y2. So now let's go ahead and substitute. Now, what's going to be our y2? We can see here our y2 is going to be -5 minus from the formula. So then what's going to be our y1? That's going to be 3 because we named there. So we have 3 over. And then what's going to be our x2? So from the naming, we can see that our x2, it's going to be 3. So we have 3 minus what's going to be our x1 from naming also, that's 4. We're going to have 4 here. So now, therefore, the gradient of AB will be, we go to the calculator, -5 minus 3 all over 3 minus 4. So the gradient is going to be 8. So now you think, you know that the two lines are parallel. If the gradient is million here, the gradient has to be million here because they are parallel. So now we can say, therefore, the gradient of that line is equal to 8 because parallel lines have same gradient. So now from the formula, we are complete. We have the gradient, we have y1 and x1. We can substitute and find the formula. So we have y minus, what is your y1? Our y1 is -2. So this negative and this negative, they will make positive. So we have 2 equal, what is the value of m? That is 8. And then we have x minus, and then that's going to be x1. So what is the value of x1? That is -3. So this negative and this negative from the formula will make positive. So guys, if you can understand, if you can relate to negative and negative being positive, you can, this is what you can do. You can write the formula y minus, and then what's going to be our y1, that is going to be -2, and then you will have -2. So I'm just skipping this step here. Even here you will have 8x minus, and then what is our x1? X1 is -3, so we'll have into -3. So I avoided that step. So now here is just a matter of simplification. 8 times x, that's 8x, plus 8 times 3, I use a calculator, that's 24. So Then I take the number on the other side, so y will be 8x plus 24 minus 2. So y will be 8x plus 22. So now that is the equation for this line that is parallel to the line that is parallel to the line AB. So now done with that question. So guys, in the next video, we will start from 2.2 and then till. So guys, don't forget to hit the subscribe button and then share the link so that a greater number of learners can be assisted. I don't claim to know anything. I'm a student of life and I will remain a student of life.